Okay, I think I've got the all clear. Okay, good evening, everyone. Thank you for coming along today. And I've just seen my first mistake that I've got neurodiversity twice. I must be very keen to talk about it, given that I've said the word twice. Okay. So the title of this talk is We're Not All the Same, and There's Nothing Wrong with That. Now, I need to make a full confession here, which is that I'm completely out of my comfort zone here. I've never given this talk before. I've had to create it in the last couple of days, and I'm not an expert in neurodiversity. I'm a neuropsychologist, and I tend to work with people with acquired brain injury. But this time I'm actually talking about neurodiversity and neurocognitive conditions. And so that's a bit of a divergence away from my usual work. So I hope that you are able to appreciate what I can tell you and hope that it all makes sense. Okay, some housekeeping to be getting on with. I'm just getting some more messages. It's too late, sorry. I'm being asked to increase the volume. I'm going to try to do that if I can. Audio settings. Okay, I've done what I can, so I hope that you can now hear me better. Otherwise, you might need to put on your headphones because this is a technological thing that I cannot do anything about. Otherwise, I will just have to shout. Okay, so I'll speak as loudly as I can. So some housekeeping. To begin with, if you could make any comments and particularly likes and questions on the Facebook page, that would be particularly useful. And I will be taking questions and giving the answers at the end. So do wait till the end of the talk, which will be in about 40 minutes or so, depending on how everything goes. So write in your questions, and my team of helpers are harvesting the questions from Facebook. They will send them to me by WhatsApp, and then I will be answering them at the end. So we've got a bit of a technological feat going on with advertising on Eventbrite, me giving the talk on Zoom, streaming onto Facebook, and questions coming through to me on WhatsApp. So let's keep our fingers crossed that all the bits work. If you're a tweeting person, could you tweet about this, please, and hashtag me as the brain guy? You will see that I'm actually a research neuropsychologist, and we conduct a lot of research in a number of different areas. I'll tell you more about that later on, and it would be great if you were interested in our research and you got in touch with us. All my previous talks, so this is talk number 13, are recorded and then edited and then put onto my YouTube channel. And so if you would like to see those talks, then you just need to YouTube Dr. Ashraf Ansari, Neuro Online Talks, and you will see my channel, which is free. And if you subscribe to that, you will get a notification when I upload the next talk. And the one from last week is also on there, will be on there, sorry. So that allows me to get going now. First of all, I want to say welcome to my friends around the world. It's been really wonderful seeing the gathering of people into my talks from as far afield as Ecuador all the way to Graham Pluck's people, also in Kazakhstan. I've got friends in India and other wonderful places around the world as well. So welcome. And as I've said before, if your country isn't represented on here, then we need to put it on here. So do text me or email me and my team, and I will make sure that for the next one, you're on there. I tend to get all my thanks over with at the beginning because I'm really just the front of house for a big team. I'm representing our team who do wonderful things to help me in terms of encouraging me to give the talks, helping me with the ideas for talks, getting material for the talks, and then helping me actually do the technology for the talks. So these people are Lofty, Pedro, Claudia, Priyanka, Nisha, Kim, Andrea, and Ida. And a number of those people are the ones who are harvesting the questions from you. But I want to say a special thank you for this young man, Oscar Nocton, who has only been at university for 2 months, and yet he's already become an invaluable part of my team. He is my technical guru and the person who's just helped me put all of this together. So I'm only here for the grace of these wonderful people who are helping me. So thank you all. As an outline of the talk, I'm going to tell you that we're not all the same, which you probably know, but I'm going to tell you a bit more about the fact that we're not. Then I'll just explore very briefly this question about what is normal and individual differences. And these are things that are very important in psychology today, which leads us into something that is prevalent across all of nature, which is the bell-shaped curve. And the bell-shaped curve is really important because it helps us understand how we all vary and differ from one another, which then allows me to talk about strengths and weaknesses, which can be within an individual or between people, which then allows me to move into neurodiversity in the cognitive realm. And I know neurodiversity is used in many different ways, but because I'm a cognitive neuropsychologist, I will be limiting myself to neurodiversity in terms of cognition. There's neurodiversity also in terms of our mental health. And so we all lie on a spectrum from extremely happy to unhappy and other mental health conditions. But I'm going to be talking about cognition. Then I'm going to move into what I think is the more important part, which is that it's not all negative, because generally speaking, anything that is not considered normal with rabbit ears around it tends to be seen as negative. And what I want to try to do is to dispel this myth and to show that there are strengths as well. And then finally, I'll talk about neurodiversity in the workplace, because this is something that society needs to talk about. Okay, so to start with, we're not all the same. Now, this lovely creature, many of you won't be able to recognize her, but this is Dolly the sheep. And Dolly the sheep was cloned. She was a replica of cells taken from her mother. And so she was actually mini-me. She was a clone of her mother. That caused controversy, of course, at the time, but this was a rather bold move in biology. And I don't know the details because I'm not a biologist. But the important thing is that Dolly was rather unique in that she was the first organism, creature, etc., that was created to be exactly identical to a previous one. But most of us aren't that. Now, these two little puddings are identical twins. This photo was taken about 53 years ago, and it's me and my identical twin when we were tiny little babies in Nairobi, Kenya. And we look pretty similar, and there usually is a bit of a competition for people trying to work out whether I'm the one on the left or the right. I won't give you any clues. But you can tell that there's a bit of a difference between the two. And about 40 years later, those two puddings grew up into these two bigger people. And you can see that although we're very similar, there are differences. So even two genetically identical people, as we grow older, our differences start to emerge. And so if people aren't genetically identical, you can imagine that there are many, many differences. And what you see here are just physical differences. But then there are differences in brain structures, and I did have a slide, which I'm not going to show you today, of our brains to show that our brains are slightly different, and then our environments are different. So the things that we've done or have happened to us have been different. And because we know in psychology that a lot of our behavior is an interaction between the genetic material that we came into the world with and our experiences, that shows that if you're already born different to someone else, like your sibling who you only share half of your genes with, then of course you're going to be rather different from them. And then you take that one step further, and if you have two people who are unrelated, they don't have the same genetics, and they'll have had different environments as well, and that will result in different behaviors. So that leads us to individual differences. Now, believe it or not, Charles Darwin was the person who started this inquiry, because his work on the Galapagos Islands was looking at individual differences and how small mutations in genes were happening between different islands, different species, within a species, etc. So as long ago as when Darwin did his work, we were already beginning to appreciate that there were individual differences, and that even animals aren't all the same within a species. And you've only got to look at two dogs from the same litter to know that they're not different. So what does normal mean? And I think that that's effectively what the point of this whole talk is. It's, I want to challenge that term, what normal means, and you'll see that I'll challenge it in a number of different ways. This is a fantastic quote I got, which is that normal is nothing more than a cycle on a washing machine. And it comes from that great philosopher of our times, Whoopi Goldberg, who I adore. So I'm really pleased that in a neuropsychology talk, I can quote Whoopi Goldberg. And I think this is lovely because normality is such a loaded term, and it results in a lot of stress for people who want to be more normal. And what I'm going to try to do is to demonstrate that neurodiversity, so being different in a neural way, isn't a problematic thing. So we're not all the same. This is known as the bell-shaped curve, which in statistical terms is known as a normal distribution. And this is something to do with, this is a phenomenon within nature, whereby when you look at most physical things in nature, you see that there's a distribution. So taking a simple example, if you went onto your street where you live, for example, if there are trees there, if you measured the heights of all those trees, what you would find is that there are quite a few trees that are very similar in height. There are some that are taller than those trees, and there are some that are shorter than those trees. So you get some that are in what we call the middle of the curve. There are many that are average, which is right slap bang in the middle of that curve at the top. And then as you go towards the right, you get trees that are going to be taller than average. And as you go to the left, you get trees that are shorter than average. You can do that with human height. So I'm a very boring average height, 5'10", and there are people, so I'd be in the middle of that curve. And then as we go towards the right, that first red circle that you see on the downward slope might be 6 foot tall. So those people are taller than average. Then you go towards the left from the middle and you get to that first red dot, and that might be 5'8", which is below average. And what you see, and so the height of that dot is always how many people are of that particular height or weight, etc. And so the height of one of those dots is how many people or observations we've got of that. And as you see, as you move away from the center, you get fewer and fewer people because the height of those dots gets lower and lower. So basically, for example, in terms of height, we wouldn't get that many people who are 7 foot tall. So they'd be on the extreme right of that curve. And you don't get that many men who are, say, under 5 foot tall. So they'd be on the extreme left. So that is something that nature has endowed, and this is something that I'm not a biologist, so I can't comment on that, but we just know it exists. And what we're seeing is that these individual differences in physical height, etc., exist in everything. And the classic example I always give is athletic ability. Every 4 years, we give gold medals to people who are on the extreme right of that curve. If we're talking about running, so it'd be running speed, the people who are extremely fast, they're on the extreme right of this curve, and we give them gold medals for running 100 meters very, very, very quickly. Whereas some of us would be more in the middle. So this is something that happens throughout nature. So we all have strengths and weaknesses, and that's an important thing. So our gold medal winner, let's say Usain Bolt or Kelly Holmes or etc., any amazing athlete, they're amazing at that one thing, but that doesn't make them amazing at everything. They're only they're amazing at that one thing that they become so good at. So I'm going to give you an example from me. So here's our bell-shaped curve. Now, so if you've understood the point I'm making, the middle bit, the high bit of this bell is average. Towards the left, it's lower than average. Towards the right, it's higher than average. So if we talked about my knowledge of the brain, then given that I'm giving a talk online right now about brain functions, I'm probably above average. And that, in fact, is a 3D print of my brain. So my brain looks exactly like that, not that size, it's a bit bigger than that, but that's exactly what my brain looks like. So I'm above average on brain knowledge. One thing that's come out of lockdown is that I've had time to stay at home, because we have to, and do more and more cooking, which has allowed me to really branch out and do cooking. And so I've learned recipes. So this is some southern fried chicken that I made the night that Joe Biden and Kamala Harris were confirmed as winning the election in the States, because I wanted to do something in honor of her southern roots and her Indian roots. So there's Indian spices as well as the southern fried chicken there. Another thing I love doing is singing. I sing for a number of choirs, and particularly my beloved choir, the London City Voices. And for this, I would say I'm pretty average. I'm never going to do a solo. I would die of embarrassment trying to do a solo, but I can sing in a group. So this is me and some of the basses, my friends Phil, David, Paul, with some of the basses, and this is our 70s concert as we're waiting to go on stage and for our amazing concert, and we're dressed in 70s outfit. And this is my beloved, what I call psychosexual family, my friends Jason, Sandra, Richard, Leonie, Annie, and Mel. So for singing, I'm nowhere near the brain knowledge ability or my cooking abilities. I'm very average. For something else, driving, I'm more or less off the scale bad. I haven't driven a car for years. I wouldn't trust me. I think it's safer if you take a taxi than have me drive. So what you see in me as an individual is that you see some strengths, some mediocrity, and a real weakness. And that's for me. So if I have that, most of you will have the same. You'll have different aspects of your life that will fall along that bell-shaped curve. There are some people who actually are almost extreme in their positions on the bell-shaped curve. And this is quite a recent thing. I'd only heard of this phrase, twice gifted, recently. And twice gifted refers to people who are gifted in one thing and therefore are exceptional, but have some form of disability, but it's actually weakness, not disability, a weakness in something else. So for example, I'm working with someone who has got what's known as aphantasia, where she's not able to mentally imagine. So if I asked you to close your eyes and imagine what your home looks like, you would have an image in your mind's eye. Someone with aphantasia can't do that. They can't create mental images. And so she has aphantasia, but she's extremely good at face memory, and she's a designer. And that's rather odd to have a real weakness in one and a strength in another. And the best estimates of prevalence range from about 300 to 360,000 people in the States, which is about 0.5% or 1 in 200 of all children under 18. And in Australia, an estimate put it at around 40,000, or maybe about 10% of gifted Australian children. So you have gifted children who have shown exceptional strengths in something, and then 10% of those also show a real weakness in something else. And this is such a new area that there's no clear-cut profile of these twice exceptional children, because the nature and disabilities of twice exceptionality are really, really, really varied. But it demonstrates that you can be as one person on both sides of that bell-shaped curve. So now I want to move into neurocognitive conditions. And as a cognitive psychologist, this interests me a lot. So cognition is our mental abilities to our memory, language, vision, face recognition, numeracy, our ability to plan and make decisions. So these are all part of our mental sphere that we need on a day-to-day basis. And there are a number of conditions that have come to the fore where people have particular weaknesses in some of these. So a classic one is dyslexia, which is a reading and writing problem. And for this, I'd like to thank Will, Kim's husband, who gave me a lot of useful information. Estimates suggest that 5 to 10% of children, and this is globally, 5 to 10% of children have got some sort of reading and writing problem. I've got to be vague on that because it's not clear where the problems lie because of something I'll tell you in a moment. Then we have attention deficit, it's not deficity, sorry, deficit hyperactivity disorder, or ADHD, where the children have a particular problem in focusing attention without being distracted, or they can get very hyper and want to do stuff all the time. And the numbers I've seen suggest that it varies between 2.2 to 7.2%. And part of this is because of the way these things are calculated. Then we come to Autistic Spectrum Disorder, which is, it's a very complicated disorder, which is difficult to define completely, but it's largely about communication and delayed language. But even there, I've had to oversimplify it. But generally speaking, kids on the spectrum have got difficulties in communicating, or they have delayed communication, and sometimes this goes along with emotional communication as well. Now, the reason that it's complicated to give numbers is almost in what I just said. It was complicated for me to define it. And if something is complicated to define, then it's complicated to measure, because you need to have a very good definition of something before you can measure it. And then the way it's measured varies hugely between different research teams, between different countries, etc. So this is data that I found, which is the prevalence of ASD among children in a number of countries as of 2020, and it's per 10,000 children. And you see that in Hong Kong, 372, they reckon. So about 3% of kids might have ADHD, ASD, whereas in South Korea, about 2.6%, in the States, it's 2.2%, etc. Now, some of these differences might lie in some genetic factors, but some of it might lie purely in the way that it's measured in different countries. And this will come down to how it's defined. And this is why research is necessary, so that we know whether these differences are actually representative of more ASD in a particular country, or simply that they're measuring it in a different way. And we saw this with the COVID statistics, that depending on the way different countries were measuring it, number of deaths or the infection rates, etc., it could vary between countries, and not necessarily because one country was worse than another, but simply because they were measuring it differently. Then we have developmental coordination difficulty, or DCD, which is also known as dyspraxia, and that's a problem in movement which isn't to do with any physical disorder. It's to do with the coordination. So kids with DCD can come across as clumsy, and I think I'm a bit dyspraxic myself. I used to have a Swahili nickname because I was so clumsy that I'd always be knocking myself and cutting myself, etc. And this is because I'm quite clumsy. Kids with DCD would have problems, certainly when they're younger, of tying their shoelaces when their age-matched peers would be able to do that. Sometimes they will walk downstairs one step at a time, rather than the way we would alternate between different steps. So there are lots of different ways that you can see some of these problems. Then we have developmental prosopagnosia, and prosopagnosia is an area that I work in, which is a face recognition disorder. And I work mainly with acquired prosopagnosia, where people used to be able to recognize faces, but now they can't recognize faces from brain damage. But there's a developmental version where the person has always been able to, has always had this difficulty. And estimates suggest 2 to 2.5%. So about 1 in 50 to 1 in 40 people have got a problem with face recognition. Now, importantly, comorbidities exist between many of these conditions. And what that means is that if you have one of these conditions, particularly the top 4, then the likelihood of you having one of the other conditions to some level, maybe not the same level, but the likelihood of you having a bit of one of the others is increased. So for example, a child with DCD might also have some ADHD and some dyslexia. So these aren't categorically separate conditions. They are, but there's a complexity underneath them which we're only beginning to scratch at, and there are probably some fundamental difficulties that we don't yet know about. Another thing is that most of these are spectra of families of conditions rather than one homogeneous condition. So that is extremely important for this whole idea of we're not all the same, that we do vary between ourselves. So an example is dyslexia. Now this is a diagram showing 3 big areas that are involved in the human brain when we're reading. And the way to look at this is as if you're looking at someone who is looking to the left. So what you see at that front of that boxing glove would be where their eyes are, and then where the thumb bit of the boxing glove is. As you go further down, that's where the thumb are, and then the back is the back of the head. Now, when you're reading, the first thing that happens is that information goes to the blue area at the back of the brain. That blue area is the visual area of the brain. So it sees things, and it's got to do a lot of visual processing to see the separate letters and then add the information from those letters to create words. Now, we just take it for granted, but a D and a B actually have exactly the same visual information. It's just that the curved bit of a D is in the opposite direction to the curved bit of a B. We take it for granted, but in fact, there's a lot of visual processing that happens to allow you to differentiate a D from a B. And if that visual processing is weakened for whatever reason because of some genetics, then mistaking a D for a B or a P might be increased, hence some sort of reading difficulty. Then once the information from that word recognition area at the back has taken place, it pushes the information further into that green area, which is known as the parieto-temporal area. And this is where you see words rather than letters. And that's where you've put the letters of one word together and separated them from the letters of the next word, and you see individual words. And if there are problems in this area, then you might mistake some words for other words. Then finally, that information, if you're reading rather than just if you're reading it aloud rather than reading it in your mind's eye, the information from there needs to be pushed to the speech areas, which are the orange areas in the front there, in around the templar area over here. And that is where you vocalize and articulate what you want to say. And if there are problems at that level, then you might have problems in actually saying the word. So what you can see is that there are at least 3 areas that when you're trying to read something, if there's some sort of problem, you could have problems in reading. It might be in seeing the individual letters in the blue area, which then makes it difficult for you to see the words as a whole. Then it's at the level of the words, and if the word area is weakened, then you might mistake one word for another. And then finally, in terms of actually articulating the word. So the result of that is that whilst dyslexia is this term that implies a reading problem, there's at least 3 areas where things can go wrong, and that's at least 3 areas. There are many more than that, and that's why you end up with a whole family of disorders rather than just one dyslexia. So you can have two, 3, 4 people with dyslexia, where each of them has got a slightly different flavor of the problem. And another thing, which is probably what the comorbidity is about, is that if you've got a weakness in a particular area, so let's say that orange area, then you might have weaknesses in other things that orange area is doing, which isn't just to do with reading. And so that's why you have comorbidities where the main manifestation or the main problem that is apparent to a teacher or a parent is the reading problem, but there'll be other more subtle problems as well. In terms of the spectrum, I want to give you an example from face recognition. So this is work that I've done with the test that I've created called the UFMT. And we did a study online where we invited people to do my test online. And what you see is what's called a histogram, where along the x-axis, you've got the number correct that you can get on my task, which goes up to 114. And on the y-axis, or the vertical one, you see how many people got a particular score. So the height of a bar implies how many people got that particular score. And what you see is a classic bell-shaped distribution, that there are lots of people who are bunched in the middle, so average face recognition. Then there are people who are at the low end of the spectrum, we're called known as prosopagnosia, but you see that they are just at the tail end of what we would call the bell-shaped curve. So you could get a couple of people with prosopagnosia, and I think there are people from the online prosopagnosia group who are here watching this talk, and you could get a couple of them, and between 2 of them, you might have quite a difference in severity of the problem. So even within the area where you would find the people with prosopagnosia, they differ from one another. Then at the other end of the spectrum, we have people with who are super recognizers and who are exceptionally good at face memory. So what you see here is that with the dyslexia, you see why it might be a family of disorders rather than just one particular problem. Dyslexia, there are a number of dyslexias. And here with the face recognition, we see that it's a spectrum, and that within the area where people differ greatly from the average, you still can have some sort of difference between individuals. So you can have people with prosopagnosia with lots of differences between them. So developmental prosopagnosia, we know that there's no known brain damage, none that we've been able to see. And as I said, it affects about 2.5% of the population. And I mentioned the Prosopagnosia Facebook group. So if you know anyone who thinks that they've got a difficulty in recognizing faces, then they should join this group, which is a nice support group online. And some researchers also, speak on it. So now I want to move to dyslexia. And what I want to do is dispel some myths and show you that having a particular neurodiversity doesn't mean that you're a failure. And I think given the number of awards this man has won, you'd be pretty happy to say that he's not a failure.
All right, so Stephen, what was and is the #1 difficulty that you have had with your dyslexia, even though you've just been diagnosed only a few years ago?
Yeah, 5 years ago I was diagnosed as having been dyslexic for my entire life, and which explained a lot of things. It was like the last puzzle part in a tremendous mystery that I've kept to myself all these years. Yeah. That basically started with just things that happen when you're a kid in school and you're a slow reader. Yeah. And in my case, I was actually unable to read for at least 2 years. I was 2 years behind the rest of my class. And of course I went through what everybody goes through, is teasing. Yeah. And I had to go through that for a long time. And so the teasing, led to a lot of other problems I was having in school, but it all stemmed from the fact that I was embarrassed to stand up in front of the class and read.
So you have always kind of...
So what you see there is this very accomplished person saying that when he was younger, he felt he had these problems. It might have been concerned about bullying or whatever, because when you're not the norm, it's very easy for others to pick on you. I know that when I was at secondary school, some people used to call me Einstein, and I found that a bit weird because I thought that was a compliment. And I said, why are you saying that? That's not a bad thing, is it? And I think I took the sting out of their tail by saying, but that's not a bad thing. So what they thought was actually, maybe they were saying it as a compliment, I don't know. But not being in the middle of that curve does mean that you might end up feeling a bit different or being treated differently. And yet you can have great strengths, as Spielberg talked about. Now, the next one takes it even further, and we'll see what this wonderful young lady says.
People understand autism through medical assumptions. They understand autism as a medical condition, a disorder, even as a tragedy. In the medical paradigm, we're taught to believe that there's a correct way to develop neurologically, that there's a right way for our brains to work, the normal way, and that any other way of developing is wrong and needs to be treated and fixed. In 2011, when I was 25 years old, I was diagnosed with autism. And it wasn't a tragedy. It was the best thing that's ever happened to me. Finding out that I'm autistic, it brought me an overwhelming sense of relief. My whole life up to that point finally made sense. My paradigm about myself shifted. I wasn't a failed neurotypical person. I was a perfectly good autistic person. After my diagnosis, I did what most of us would probably do. I went to Dr. Google and I started researching autism. Eventually, I upgraded from Dr. Google. I did my PhD in autism, became a doctor myself, and today I'm proud to be one of a growing number of openly autistic people working in autism research.
So what I really like about this video is the way that she says that she can be open about her autism. Whereas when people find out that they've got this label, usually what happens is that it's seen as a negative, and it's very difficult for people to talk about it and admit that they've got it. And it feels like coming out. And that's what she was saying, that she could be open about this and she could just own it. And I think it's really important that neurodivergent conditions are just seen as part of normality, so that people can just say it's like being left-handed, for example. It's not something that is aberrant. So I really like that aspect of what she says, that it is just part of the normal experience for some people. There is one end of autism which can sometimes get confusing, known as Asperger's syndrome. And it's a form of autism with less severe symptoms and the absence of the language delay. And that can make it very confusing to try to diagnose. And frequently, these people have very good language and cognitive skills, so it makes it a bit more difficult. And to an untrained observer, a child with Asperger's may just seem like a neurotypical child behaving differently. And I'm not an expert in this area at all, and I'm sure there's a lot of debate rages, and some people actually wonder whether Asperger's is different from autism. And sometimes Asperger's is referred to as high-functioning autism. But we know that there are people who share a lot of common traits with what was classically called autism, who don't behave in the way that we think of as autism. But then they can also have, the people with Asperger's can have enormous strengths. So this is a man called David Tammet, who holds or certainly in 2004, held the European record for pi, recounting it to 22,514 digits in 5 hours and 9 minutes. So he's got incredible intellect. He speaks 5 languages and apparently even created his own language because he felt that the languages that he could speak weren't sufficient for him to be able to express what he wanted to. So what we see here is someone who has been diagnosed with this Asperger's disorder, and yet has these prodigious skills with something else. It might be that today we might call him twice exceptional, but who knows? So what we see is that whilst we might have a stereotypical idea of what autism is, there's a big spectrum, hence Autistic Spectrum Disorder. So all these people are part of society. We're all part of society. So that affects our workplace. And it's estimated that around 1 in 7 people, so more than 15% of people in the UK, are neurodivergent with ADHD, autism, dyslexia, or dyspraxia. And this from ACAS data that we got. And importantly, it's been shown by researchers, observers, etc., that people with these neurodivergent conditions aren't people with disabilities. They've got different strengths. So remember me with my strengths and weaknesses. So people with ADHD can be quite good at completing urgent or physically demanding tasks and pushing through setbacks and showing passion for work. So the ADHD, the bit that might sound negative, can actually be really useful at some levels. people with autism often they work very hard, they're punctual and rule observant, and they're very thorough, and many develop special interests and hold real high expertise in their given topics. So you often find that people in quite prominent positions have got some level of autism, and it's because of their attention to detail, which can sometimes be a marker of autism, or certainly Asperger's, can actually be the thing that drives them to the success that they end up having. And people with dyslexia tend to be very good at creative thinking and problem solving, storytelling and verbal communication. And you saw that with the Steven Spielberg example. And I think Keira Knightley has got dyslexia as well. People with dyspraxia, they have very good literacy skills and can be very good at creative, holistic and strategic thinking. So what we see here is that while previously I'd given you the prevalence of these conditions, and tell you what the difficulties are that they experience, there are lots of strengths that they have as well. And I think that it's important to notice this. And here is a video of someone who's discussing how managers can support neurodiversity. So he's got autism and he's talking about how managers could help people with autism. Oops.
Being on the autism spectrum at work affects me mostly in the way I interact with my colleagues, because I have to effectively think manually when I'm interacting with people, which has the disadvantage of it does take up a bit of mental capacity, but it does have its advantages. You sort of see things that people who just do it automatically may not have seen. The biggest key to making a success of neurodiversity is understanding and listening to the person as to how they work best. The way you'll get the best people is by creating an environment where everyone will show off their best abilities, and then from everyone showing off your best abilities, you're picking the best candidate rather than the candidate that best adapts to the recruitment process. It tells you what you're looking for rather than lets you show what they can give.
That it is possible and very possible for people who are neurodivergent to actually use their strengths. And as long as organizations, schools who have children who've got these conditions, and especially workplaces, are able to see these and use the strengths of people with these conditions, they're not seeing them as disabilities. And that's why it's really important that we don't see these as disabilities. They're just different. They're not neurotypical, but that in itself isn't particularly important. Now, finally, this is a wonderful video of a prominent researcher, John Steen in Oxford, who's a physiologist who's interested in dyslexia and also the genetics of dyslexia. And you will see why I think this is so important.
There are more artists who are dyslexics than you expect. There are more architects than you'd expect. There are more entrepreneurs than you'd expect. There are more engineers than you'd expect. Now, all those things have something in common. That is to say, it means you have to have a holistic outlook on life rather than being good at sequential things. Reading requires sequencing the letters and the words and making sure you know where they are in the right order. Whereas artists require really to see a whole scene and see how all the bits fit together. Now, dyslexics are much better at that than they are at these sequential things. It's clear that there are more dyslexics among artists, architects, etc. But it's often argued that that is because people who are dyslexic are bad at reading, and therefore they are diverted away from things that demand a lot of reading into things like being an artist, etc. But the balance of evidence now suggests that actually dyslexics are not just forced into these kinds of pursuits, but they are actually more talented in them. And you can test that in the lab by testing things like their ability to spot figures in a cluttered scenery, or their ability to discriminate colours. A lot of what we call holistic kinds of visuospatial tasks, dyslexics are better at, and that's absolutely clear. So that suggests very strongly that they do have superior talents. And that's only to be expected, actually, from a genetic point of view or evolutionary point of view. The fact is that dyslexia is extremely common. About 10% of people have it, particularly boys. That means that there must be compensating advantages, because if it was all disadvantage, that gene or genes, we now there's at least 7 genes involved, those genes would have disappeared, because they, one of the things we know is that many dyslexics have poor motion a poor ability to pick up motion, and if you had a really serious deficit in that regard, you wouldn't see the oncoming saber-toothed tiger, and you wouldn't live to procreate your genes.
Okay, so what I really like about that video is that this expert in the field is talking about dyslexia not as a disability or a wrongness, but actually as a gift. And it gives that really interesting take on it, which is about the genetics, that he says that there are certain genes that they're beginning to identify. And most of these conditions, there is a genetic story. We don't know how much of it is genetic, but we do know that there's genetic inheritance involved, which is very complicated. But if there's a genetic story within it, the simple thing he's saying at the end there is that from what Darwin started, theory of natural selection, if the things that make you dyslexic are that bad, then you would have been taken out of the gene pool, because you would have got eaten by the saber-toothed tiger or whatever. And so each of these conditions that we might deem to be a bit negative, they're probably not quite as negative as we think they are. And maybe they're negative in modern society, and maybe modern society, that is the issue. Now, importantly, when we look at dyslexia, when we think about the genetics here, there can't be genes for reading, because reading is actually something that is within the human evolution. It's only been around relatively recently in the last couple of thousand years, and in the general populace, maybe for 100 years or so, and there are still illiterate societies. So this gene that is with dyslexia can't be for reading. It's for certain skills. That reading, which a big part of it is up here in the left temporal areas, it's just piggybacked onto skills that the brain was already involved in. So the visual processing that happens at the back of the brain, and then putting it together for that word form area. So that word form area, it didn't just create itself, it's been there doing other jobs. And so the genetics implies that there's some weaknesses there, and it's for whatever those areas of the brain do, but there's probably compensation in terms of strengths in other areas. And those are the things that he says people are very strong at. But because of the way modern society works, dyslexia is something that is very easy to notice when someone has great difficulty reading, and you don't need to be an expert to know that someone has got problems in reading and writing. So because of the way we favor verbal communication, particularly written communication, it's actually quite easy to notice this. But the strengths that these people have are not seen that easily. And I think that there used to be this idea that people with dyslexia have problems with their reading and writing and whatever at school. And so they almost absent themselves from that and go and do other things. And then they end up developing these interests in the creative arts, etc. But what Professor Steen is saying is that, no, that's not the case. They've got a weakness which is the reading thing, but they've got a real strength in the other thing. It's not a compensation against being poor at reading. They actually have that strength. But in psychology, for example, one of the big things that we don't know is how do you define creativity and how do you measure it? You can measure reading ability really easily, but you can't measure creativity as easily. But one could say that Steven Spielberg has demonstrated his creativity very amply. So I think one of the things that's happening here is that we're seeing some problems that someone who's got the genes that have caused the dyslexia to demonstrate that problem, which happens to manifest itself in terms of not being able to read certain words, but the strengths that they have take longer to appear and become obvious. And I think that that's the biggest take-home message from here, that people with dyslexia and the other conditions I've talked about, they do have these weaknesses and we can't deny that. But that doesn't mean that they don't have real strengths. And maybe it's the case that those weaknesses are actually compensated for by strengths in another area, so that we're all a combination of strengths and weaknesses, and the conditions that we're seeing just make those weaknesses come to the fore in a way that our education system can notice it straight away. A child has to sit still or stay focused, etc. And a child who can't do that will be marked out as having some sort of attentional problem. If you're at school doing physical things, woodwork, etc., and you're clumsy, that will appear very quickly. But it doesn't allow the strengths to come across as easily. So I think that the Professor Steen's way of describing dyslexia as a gift, I don't think is even just a kind of prettifying of the issue. He's actually telling us that there are real strengths here, so not to see it as a negative thing. So to summarize, we are all different to one another. Therefore, that begs the question, what is normal? Most of us have a combination of strengths and weaknesses. And most cognitive abilities, reading, writing, mathematical ability, etc., lie on some sort of spectrum. And those at the low end of these spectra have been considered in the past as having disabilities. However, research is beginning to demonstrate that while these neurodiverse individuals do have weaknesses in some abilities, they also have strengths in others. And therefore, the education system needs to acknowledge this and harness the strengths of neurodiverse children. And then employers can also support adults in a way that benefits the neurodiverse individuals, the business, and society as a whole. So creating a lovely win-win-win situation. So that's the end of the talk. I just want to let you know that I run a rather active research group, and we'd love to hear from you if you're interested in taking part in our work, which is on memory, face recognition, and the way the front of the brain manages behavior, which is actually implicated in most of the conditions that we've been talking about today. And we're actually doing some work on dyspraxia, for example. So if you want to get in touch with us, this is our email address, which is art.gold.mind@gmail.com. And if you're able to, please include this information, your name, your age, your gender. And if you wanted to take part in any of our studies, if you have a particular condition such as epilepsy or cognitive difficulty that you'd like to tell us about. But I also am happy for researchers to get in touch with us if they're interested in the research that we're doing. Because we're very happy to collaborate and share our resources. You can find out more about ART, which stands for Ashok's Research Team, by visiting our website at gold.ac/artlab. So I'd like to thank you for your patience while I got through the nerves of the initial technical stuff. Do tweet about this if you can. The next talk is going to be a very special talk. The next talk is an interview. I'm going to be talking with a wonderful man that I met about 5 years ago, called David, who had the misfortune to suffer from a heart attack, and he had to be shocked back to life a number of times. And during that episode where effectively he was technically dead and he had to be resuscitated and shocked back. There was interruption of blood to his brain, and as a result of that, there's some brain death in certain areas, and David has been left with acquired prosopagnosia. So this is a face recognition difficulty where David finds it virtually impossible to recognize familiar people, including his family members, unless he knows he's expected to see them. But in this session next week, rather than me talking about the research about prosopagnosia, I'll be interviewing David. So I will interview David about what it means to live with brain damage and what it means to live with this acquired condition. And the audience can ask him questions. I'll give a brief overview of prosopagnosia before, but David and I have done this double act a number of times before during other public awareness things that I've organized, and it's always been an extremely well-received interview because you get into the real issue of what it means to have brain damage. And finally, as has become traditional, I just want to dedicate this talk to my wonderful mother, who is lovely. Okay, so what I'm going to do now, I'm just going to have a 2-minute break. If you have any questions, please write them into the chat, and my lovely helpers are harvesting those questions and they'll be sending them to me by WhatsApp, and then I'll be back in a couple of minutes to answer your questions. Thank you. Okay, all right, I'm back, and as has become another tradition, I've managed to go and get some nice Montepulciano that I'd opened the other day to reward myself for getting through this talk. And cheers to Oscar for his fantastic help, and to my wonderful team who are harvesting questions for me. Okay, so I'm going to now try to go through the questions and see what we have here. Okay, so the first question is from Shabs Taslim, who said, so is it language usage that such conditions are deemed negative? That's a really good question, Shabs, because in fact, there's a movement now within certainly psychology to stop referring to people with talking about people with a noun. So for example, rather than talking about a dyslexic, you talk about a person with dyslexia. You don't talk about prosopagnosic, you talk about a person with prosopagnosia. And the point here is that you're saying that this is one of the person's attributes rather than you're defining the person by the label. And I think that's a really powerful thing, because it's very easy if you talk about the dyslexic that you're effectively saying that that is the most important thing about them. The color of their hair, their eyes, etc., now is no longer as important because they are the dyslexic. Whereas a person with dyslexia could be the person with blue eyes, with black hair, etc. And so I think the idea is to move away from labeling people as conditions, because there's a loaded element there as well. So I think that there's a couple of elements there. One is not to call the person the condition. And then the other part, which is my bell-shaped curve and spectrum idea, is that we're all a bit dyslexic. We're all a tiny bit autistic. It's just that it take a long time to find that in some of us. So rather than seeing it as this categorical cutoff, where to the left people are condition X and to the right people are normal, we instead see it as a case of a person who's got a difficulty in X, and that's it. I have a difficulty in driving. If someone could come up with the term for that, then I would be that. I'm completely rubbish on that. So thank you for that question. Sophie Brown has asked, let me have a glug. I wonder what the crossover is between ADHD and an anxiety disorder, in that both can impact on being able to focus. It's an interesting question, but I wouldn't want to go there. I think with anxiety, it's more an emotional overwhelming of the system, which means that your system is just on high alert. And that high alert means that you can't really focus on the nice wine or the nice conversation you're having, because you're being constantly vigilant. Whereas I think with ADHD, it's more that something happens over there and your attention can be dragged in that direction. So I think that the process of the lack of focus is different. With one of them, it's because of a heightened emotional state, which effectively depletes your resources and makes it very difficult for you to stay focused. Whereas with ADHD, I think it's that the filters that we have that allow you to stay focused, maybe they've gone a bit wobbly, and so something from over there can grab my attention a bit more. Now, I'm not an expert in either condition, so I can't say. So that's just my my suggestion of what it could be. Okay. The next question we have is from Bruno Stanford says, why is everything partaking to boys in the neurodiverse world when girls can be affected too? Yes, absolutely. So I think with a number of the conditions that I've talked about, there are gender differences, and I don't know them because I don't work in the areas. But for example, in autistic spectrum disorder, there used to be this idea that I think boys were 4 times as affected by it as girls. But more recently, I think people are beginning to see that maybe it's that the manifestation in girls is different to the manifestation in boys. And if you take the example I gave about the dyslexia, that a reading difficulty is very easy to see and therefore to diagnose. And so noticing an issue like that becomes very apparent. So I think in ASD, maybe it's the fact that the primary issues, which are the communication delay and an emotional distance, maybe those are more apparent in boys, and in girls, they manifest in a different way. That's just my conjecture. So I think that there's a lot of work to be done yet on gender differences in these conditions. And since I don't work in there, I can't say for certain, but I think that it's not quite as gendered as people used to think it is. Okay, next question is from Barbara Georgelis, who I think is an A-level psychology teacher. So, hello, Barbara. Barbara has asked, does anyone with prosopagnosia recover? Do other brain areas ever take over that function? It's a good question, and sadly the answer is no. I don't like being a harbinger of doom, but I've never known of a person with prosopagnosia to recover, just because the area that is involved we think is so complicated that it's doing things that we're only beginning to scratch the surface of. And although neuroplasticity, which is I think what you're referring to, that the brain can repair itself to some level, does exist or occur, it probably can't happen for very complex functions. And so trying to repair very complex areas which are processing very, very complicated information is going to be more difficult. So we haven't seen any evidence of it whatsoever. And I've been working in prosopagnosia for 17 or so years, and I've never heard of a person with prosopagnosia actually recovering, unfortunately. And it may be that with some of the other functions, like with memory, where we know that people with amnesia still have some intact memory functions, which are called procedural memory and implicit memory, and we can harness those to try to teach new skills. What we're effectively doing is we're going around the problem, so we're helping the person learn something without explicit awareness of what they're learning, which would be called memory. So they don't have the memory of learning it, but we know that they're learning it. In face recognition, we just don't have that. And I've tried to rehab study it, and it was almost as flat as a pancake. And I don't think it's because I was a rubbish researcher. I think it's because it's a difficult area. So the next question is from Janet Cawthorne, which is that I've often wondered about traits of ADHD being those that were very adaptive for survival in other areas of evolution. That is a peach of a question. That's a real peach of a question, Janet. I think you've really got to the heart of the issue there. Because Janet is saying that the traits of ADHD, they might have been the thing that helped us adapt to different environments. So maybe it was useful that if you heard a little sound there, that you noticed it straight away, that you always had the energy and you were at that level. So what we now call hyperactivity, that you could get into that state really quickly. Now that actually might have survival advantage. Being able to notice something that other people might ignore, we might call that distractibility, but maybe it's actually heightened awareness, and that having that energy level, which we now call hyper, maybe that was really good. And in a pack, it would be useful to have people who were like that. And so in a way, genetics isn't about, and I don't know genetics very well at all, but genetics isn't about an individual. It tends to be about the combination of genes that help survival into the next generation of genes and the next generation, etc. So if there's a combination of genes that are actually generally useful, then across a group of people, so let's say a family or a tribe, it's necessary for some people to have those genes. So I think that's a really, really, really lovely question. And it may be that what we're seeing in ADHD is some of these genes that were really important at a particular point in evolution that are still there. And this really nicely kind of dovetails into what I was saying earlier, that maybe it's modern society that's wrong. That modern society requires us to sit still and be really focused, etc. And it's modern society that's the problem, rather than the abilities of people with ADHD. So thank you. That's a really nice question. Okay, next question. From Jane Antoinette Croucher, thank you. Jane has asked, how are workers with Asperger's syndrome affected by increased homework and meetings by video conference instead of in person? Do they prefer or dislike this type of working? And she's asking because her office has a high proportion of workers with Asperger's syndrome, and we're basically 100% home working now. I think that's a really interesting question, but the data will follow because I don't work in that area, but I imagine that people who work in Asperger's, and particularly in terms of Asperger's in the workplace, for them this will be really important to look at, because that thing about change in pattern will be really important to see how people have adapted, because we've all, even those neurotypical, however you want to call us, people who've had to adapt to home working have found it's a transitional thing, and some of us are finding it easier than others for a multifarious range of reasons. So someone who's used to routine in the way someone with Asperger's might be, they might be more affected by it. Now, there might be pros and cons in that maybe home working might be easier because there's less of that social contact, which might be more problematic. So I think it's going to be an open question, but I imagine the people who work in employability of people who are neurodiverse, they'll be looking at this very closely. So thank you. So this next question is from Emily Smart, who's asked, I have prosopagnosia, but have not managed to get a diagnosis for it, as most GPs and disability services who I've talked to do not know about it. Do you have any advice on what is the best way to seek help for it is, and how to get diagnosed officially? That's a useful question, Emily. Please do write to my team to the details that I provided earlier, because we have our tests for face recognition, because it's not considered at the moment as a disability, and I don't think it is a disability, but I think that's a moot and a philosophical point. They wouldn't know what to do with it. and most people haven't even heard of this term. I've spoken to so many people. I mean, even people who work in psychology haven't heard of prosopagnosia that much. So it's unsurprising that the GP hasn't heard about it. So I think that this is why public engagement like this is really important. And one of the things that I want this talk to do, and we will be moving into addressing workplaces in the future with this talk and maybe workshops, etc., is what can we do to help people in the workplace who've got these different conditions. But because at the moment it's not considered as a problematic issue, that's why there won't be a diagnosis, and certainly it's not considered a medical condition. Even for our students at university who've got dyslexia, dyspraxia, etc., they have to get certain assessments, but those assessments are done by experts who work in those types of conditions. They don't happen by a GP or a doctor. So what I would say is to email us to the email address that I gave, and I'm instructing my helpers to put that email address again into the chat, or you can email me to a.jansari@gold.ac.uk, and Claudia, who is working on prosopagnosia for her PhD, will be able to send you a suite of tests that we do, and from that we can give you an indication of where your strengths lie, because we run a fairly active prosopagnosia research group. Okay, the next one is my friend Katrina McIntosh. Katrina is a very lovely Scottish clinical neuropsychologist based in York. And Katrina has asked, Ashok, did you know that difficulty learning to drive is common in dyspraxia and dyslexia? There's evidence that both are linked to the cerebellum and difficulty in learning overlearned skills. This applies to learning to read, drive, learning languages. That's really interesting, because a number of years ago, I had an undergraduate student, Ros Watling, who wanted to do a research study with me on something I'd never heard of. And I said, what? He said, dyspraxia. I said, what? Dyspraxia. And so she said that it was this thing which lots of kids had, and one of her children had dyspraxia, and she wanted to do a study with it. And because Ros is a very, 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 very competent and strong undergraduate student, and when she said she wanted to do something, I knew that she was serious. I thought, okay, I can trust her to go for this, and I'll help her as much as I can. So I helped her design the study. And then it was only while I was reading things that she'd written that I thought, that's me. I've always been classed as clumsy. And my mum, my darling mum there, she eventually forbade me from going into the kitchen, because I'd be an eager little puppy wanting to help, but I'd end up just chopping my fingers and blood everywhere and knocking things, etc. And my siblings used to have, we grew up in Nairobi, used to have a Swahili nickname for me, which is Kisrani, which means bad luck, which got shortened to Kiss. So my nickname as a child was Kiss, but my mum knew that implied bad luck. And so when we moved to England, when my twin and I were severed, at some point our mum forbade my siblings from calling me this name, because it implied that I was such a clumsy idiot. And so for me, it was rather interesting that this thing that I'd lived with all my life, being a bit rubbish, was actually possibly a condition. But and yet I can learn languages quite easily. So, but this shows that spectrum thing, that you can be a bit dyspraxic, which I think I am, but you don't have to show all of those things. I do actually find reading not so easy. I mean, I read, but I read really slowly. So I think I need a diagnosis. Do you know a neuropsychologist that could diagnose me? So Viv Ellis is the next person with a question, who's asked, I have prosopagnosia and I've always had it. It's not acquired, but it seems to be getting worse as I'm now getting older. Is this due to usual aging of the brain? That's a very good question, Viv. I would say that it's probably not prosopagnosia that is getting worse. It's probably your memory, and you've got what's called normal, which is normal age-related memory loss. We're all getting older, and memory for all of us is, weakening a bit. I've got a memory like the oldest she-elephant around. I really remember things, which isn't good some of the time. But I'm finding that I'm sometimes finding it a bit more difficult to remember things, and I'm forgetting things in a way that I didn't. And so I think that this is something that we all experience, but because you're already attuned to the fact that you can't recognize faces, you may be associating the difficulty in remembering a name to go with someone, and that sometimes being a bit problematic now as you get older, as your prosopagnosia getting worse. But I doubt that the prosopagnosia getting worse. But I'd be interested to know more about it. So if you would be interested in doing our studies, then we could send you our studies and then see whether there's a pattern there. It would be interesting to see. So again, if you were happy to get in touch with us, it'd be good to hear from you. And the thing that I just want to point out with what I was saying to Viv there is that with prosopagnosia, it's not a memory loss. People with prosopagnosia don't have bad memories. They just can't associate this thing to a face. And if I had funky hair and that funky hair was always my signature, a person with prosopagnosia would know who I was, even if you put that in front of my face, because they're associating my hair with my name. And so they can remember me easily, and they can remember things about me, etc. It's just that if you showed them this, they'd say, I don't know who it is. So, that what I'm saying to Viv is that maybe that other information is the thing that's weakening with time, and that is completely normal. Okay. So the next question. Louise says that she's got ASC and gender diagnosis. I'm not sure what you mean by that. Louise, do you mean ASD? Could you just clarify that in the question in the chat, and I'd be happy to answer that if I can. So Shabs Taslim, Shabs is asking a second question. What's normal? Because we're all born different. Even the early years foundation state stipulates each child is unique. Exactly, and I think that is why I started with the Whoopi Goldberg example. I think that we're moving away from maybe a Victorian and Edwardian idea of how people fit into certain boxes, and you're supposed to be this, where society prescribes rules for you, rules and roles and abilities. And so you're told what to do or what is expected of you, and any divergence away from that is wrong. And the LGBT movement is an example of that, because that completely didn't fit in with what the Victorian world would have had people do. And so I think normality has been defined by society. And when that becomes codified in a particular way, and it's codified in terms of, for example, education, that a lot of education, and I'm the product of that education, for example, I was a bloody good SWAT, it favors certain skills. But if education had been based on motoric skills and coordination, I'd be in the dung heap because I'm so clumsy. So I think that it's about the way society has defined things. But as I said with the bell-shaped curve, a lot of this is actually there in biology anyway. But I think that the way we define it and the way we see anything away from the norm in what we call the tails of the bell curve, whether we see those as wrong or not, I think that's the issue. And I always use that example of the Olympics for showing that we're quite happy for people to be at that end of the curve, the really good end of the curve, or the high end of the curve, but we don't seem to be that happy with people being at the other end. Now, of course, if that other end of the curve, the left-hand side of the curve, is problematic in terms of people's lives and the way that they progress through life in their health, either mentally or physically or emotionally, then that is problematic. Then I think helping them to live a more satisfied life is really important. But I think it's about how we define that normality. And at that point, I think I'm veering into philosophy, and I can't even really spell philosophy, so I'd better be careful. But I think that is an issue. Yeah, it's the way language, it's the way society ascribes what is normal and how we value. Actually, it's more about how we value what isn't in the center of that curve. That's ultimately what it comes down to. However we define that bit in the middle of the bell is one thing, but it's what we think about the bits on either side, I think, is going to be a challenge for society. Yes, Susanne, this is all being recorded and it can be rewatched. So I think that what we've got, Louise was saying that regarding the question on ASD and gender diagnosis, I think there is research around girls being able to mask their condition more than boys. That may be a reason why boys are diagnosed more. Thank you, Louise. So that's kind of what I was saying, that maybe, I don't know if it's about masked. I think it's that it manifests differently. I actually saw a report about a year ago on local news about a school in Sussex, which is only for girls with autism. And so it's not just it's a school for people with autism, it's for a school for girls with autism. And I think it's because they probably are treated differently, and some of their difficulties are more masked, and that results in the boys being overdiagnosed or being diagnosed more, hence the kind of skewed gender balance that's seen. Okay. Okay, that's all of the questions I've got so far. So I'm going to see if there are any more questions. I'll wait. If anyone wants to ask any more questions generally about the talks or the series, I'd be happy to answer them while I enjoy the rest of this lovely Montepulciano. A couple of weeks ago, I told everyone about Diwali. I don't know if I can tell you another story, although as my students will testify, I'm very good at just telling stories just for the hell of it. So do we have any more questions? I think Facebook has had enough, and especially those in the UK are getting ready for Strictly Come Down soon. Maybe it's already started, which is why questions are finished. And Mum, if you can see me. Janet Cawthorne has asked a really good question. I'm liking you, Janet. Can we become friends, please? Janet has asked, how is your wine and would you recommend it? It's a lovely Montepulciano and I would recommend it. Here's a bottle. It's I think it's called La Puma from Mrs. Waitrose. It's very nice. I've just diverged away from my main one, which is Primitivo. So yes, I would recommend it. And you must get in touch because I like you. I like your questions. One thing I should say here for those who haven't gone to watch Strictly is that I don't know how many more of these talks I'm going to give, partly because I'm now veering into areas that I don't know well, so this being an example. But if people have ideas of areas that they'd like to hear more about, please say them in the chat or email my group, because I'm willing to develop new talks if I feel that I can say something that is somewhat useful and interesting. So I obviously will stick to my strengths and the areas that I know well, but I'm also willing to see what I can do in terms of decoding some of the complex language around some other areas, if I think that I can provide some sort of service like that. So if there are areas that people feel that they would like to know more about, that they think that a nerdy cognitive neuropsychologist like me might be able to help with, then do let me know, or us know, and the team and I will look into it. Okay, I'm just going to ask my team whether that's it for questions. Susan, I think what you need to do is to look at my the video, the YouTube channel, because I did give a talk about improving memory. So there is already a talk about memory and trying to improve your memory. So I hope you find that useful. Yeah, we've already had that. So I would, if I were you, put into YouTube Dr. Ashok Chansari Neuro Talk, and you should find my YouTube channel. And there's a playlist there of Neuro 2020 talks, and in that you should find one about memory, forgetting and improving memory, in which I've tried to give some sort of help and guidance on that. Come on, Janet, I'm waiting for you to say something else now. I'm missing you. Or maybe Janet's also left me for Strictly. Okay, help team. I'll need to you need to let me know whether we're done now. Okay, I've just been told that there are no more questions, and so I think I'm going to wrap it up now. So thank you very much for participating, attending this talk today. Thank you for your lovely questions. Thank you for your patience during the technological bits, etc. And most of all, thank you to my wonderful team of helpers and to Oscar. You all rock. Bye.